Hello everyone. In this video, we're going to talk about vertical and horizontal shifts. Now I'm going to break this into two videos. In this first video, we're going to do this top section here where we go through example one here. But at the bottom here, there's a couple more examples that I'll do on a follow-up video, okay? So at the top here, we have all of our shifts. We have two vertical shifts and we have two horizontal shifts. Let's talk about the vertical shifts, all right? So notice how the constant that we are attaching to the outside of the function here, that creates a vertical shift, which is why we say you're looking for numbers on the outside of the function, because we just attach them to the end, okay? They're not inside where the f of x is. Now, if you see that it is a plus c on the outside of this, if you see a plus c, that means we are moving up the y-axis. We're shifting the graph up. So this corresponds to we are going to add the constant to our y values. Add to our y values, and vice versa. If we are subtracting the c value, we are going to subtract from our y values. Subtract the y values. Okay, now let's move on down to the horizontal shifts. Now notice the constant has moved inside the function. It's inside that parentheses, so it's now f of x plus c. Okay, so that's why we say that this is now inside the function. Inside the function. So another thing that I want you to notice is now it says x plus c. So you're probably thinking to yourself, oh, this must be a horizontal shift. If I'm going in the positive x direction, I must be moving to the right because that is the positive x direction. But look what it says. It says it's shifted to the left. Well, why is this? Well, I'll tell you why. Let's say our c value is 3. So we have x plus 3, and it's in parentheses, right? Well, this looks like a factor of when we factored out a quadratic. So what did we do to find the actual 0? We set that thing equal to 0 and solve for x. And we see that the x value is actually -3. And if we go to the -3, we actually move to the right, or to the left, excuse me. Okay, so that's why it's flip-flopped in your head. You just got to keep that straight, okay? So if you see that you have an x plus c here, x plus c, that corresponds to what are we actually doing? We are moving to the left, so we are actually going in the negative x direction, so we're going to subtract from our x values. And vice versa. If we have x minus c, we are actually moving to the right, which is in the positive x direction. So now we are going to add to our x values of our key points. Those are from our key points, okay? All right, so last thing I want to talk about for the horizontal shifts. Well, what does it look like if it's inside? Lots of people say, well, what does it look like if it's on the inside with all these different parent functions? Well, if it's on the inside of a square root, you'll see in the first example here, not square root of a quadratic, you see x plus c, but then you'll have the square on the outside of the function there, okay? So now, same thing for cubic, x plus c, the cube is on the outside, so that constant is on the inside of the function, okay? What about square root? If it's on the square root, it has to be underneath the house. Anything underneath the house is deemed inside the function, okay? The reciprocal is a little funky. If it's inside the function, it's going to be on or in the denominator of the fraction. Anything down there is inside. And last but not least, we have our jail bars here, which I call them jail bars, but it is the absolute value. Anything inside of that is deemed inside of the function. So let's do an example here. All right, example 1. So how are we going to do this? Well, first thing that we're going to do is we need to identify the function, the parent function. Identify the parent function. Okay, how we do that is if I took all of these numbers away, except for the exponent up there, what do I get? All I see is an x squared. So this is a quadratic. Okay, and if you want to draw yourself a little picture just to remind yourself what it looks like, it's that little u. Okay, all right, so next step is now we need to identify our shifts. Okay, so I need to get rid of these black markings here because I need to see. Let's do it in green. So I need to identify our shift. So I'm looking inside or outside of the function. I'm going to look inside first to see if I have any of those. I do. I see it's x minus 3. So I have a horizontal shift to the right. Why is it to the right? That's because x minus 3, the x value is actually positive 3, which I'm moving to the right. So I'm actually going to add 3 to my x values, which is going to shift the graph to the right 3 units. Okay, now I see something on the outside as well. I see I'm adding 1, which is a shift up. I'm shifting it up 1 unit, which means I'm going to add 1 to my y values. Okay, now third step is we need to adjust our key points. Okay, so let's recall our key points for the quadratic. We have 0, 0, and we have 1. 1 squared is 1, and then we have 2 squared, which is 4, and then we got to do the other side. So negative 1 squared is 1, and negative 2 squared is also 4. So we're just going to adjust these using the shifts that we have identified here. So let's do our x values first. Our x values, I'm going to increase by 3. So the vertex is going to go to 3, 1's going to go to 4, 2 is going to go to 5, negative 1 goes to positive 2, negative 2 goes to positive 1. Now we're going to do my y values. My y values are increasing by 1, so that goes to 1, that goes to 2, that goes to 5, that also goes to 2, and that also goes to 5. Now I have my brand new shifted points from the original parent function. Now you're just going to plot those and graph it. Last step, plot and graph. Gee, there we go. Plot and graph. So I have 3, 1, 4, 2, and I have 5, 5, and it's a mirror of itself, so I can just do this. There we go. And then we graph. Make sure it's nice and curvy, and it had your arrows on the top. That's it. So that's how we graph these things. So just to recap, your first thing you need to do is identify your parent function. Then we need to identify the shifts. You're looking inside the function or on the outside of the function. Okay, and then you take your key points for whatever parent function that you have, and you just adjust them based on the shifts that you just did, and then just plot those new points and graph. It's as easy as that, folks. I hope you're all staying healthy and safe during this time. I will see you on the next video where we go through examples 2 and 3. See you then, guys. Bye.